Hello, Algebra students. Mr. Lawrence here, and today we're going to be adding and subtracting in scientific notation. It's a little bit different than what we did yesterday, where we just multiplied the coefficients and then multiplied the bases together because the bases were like. In this case, it's a little bit different. If you stop and think about 3x to the fifth plus 2x to the fourth, you better not try to tell me that's like 5x to the ninth. No way. You better get down and do 5 push-ups. You just said that. Or if you think it's like 5x to the fifth, 5 more push-ups, do them. Come on, push that floor. Here, they're not like terms, right? These are x to the fifths, and these are x to the fourths. We can't add these together, okay? So if we had, say, a problem like this where we had, I don't know, 2 and 5/10 times 10 to the third, and we were adding, I don't know, 1 and 3/10 times 10 to the third, these would be like terms because we have 2.5 10 to the thirds, and we have 1.3 10 to the thirds. So we could say, how many 10 to the thirds do we have, right? We could say, well, we've got 3.8 10 to the thirds, right? Okay, remember those tens with exponents, they behave just like variables. They're not variables, but the rules are the same. That's really cool because the rules of math don't change based on the situation. All right, so they have to be like terms to be able to add them together. Well, if I look at problem number 1 here, I see I've got 10 to the thirds and I've got 10 to the fourths. You can't add them together. But the cool thing is we can manipulate them so that they are like terms. I like to change my smaller exponent to match my larger exponent. It's not always the easiest way to do it, but it usually is. So I'm going to change this 3 into a 4. Well, how can I do that? Well, of course, I'd multiply by 10 to the first power, causing this to become 10 to the fourth, right? I'm not going to use this, I'm not going to alter this 2 and 22/100ths number yet, so I'm just going to write it down. But just like yesterday, if I manipulate this part of the number, I have to manipulate the other part of the number in an inverse way. So I'm going to divide this by 10, okay, causing this decimal point to move here. Remember, if the exponent goes up, then the decimal part of the number has to get smaller. It's an inverse relationship. So I'm going to have 0.111 times 10 to the fourth. Now, I'd much rather add vertically. I'm going to line things up. 2.22 times 10 to the fourth. And I'm adding, change the order because it doesn't matter. Line up my decimal points. Don't forget to do that. Oop, I'm going to need a 0 placeholder. I'll put it in a different color in case you're wondering, where it came from. And this is times 10 to the fourth. So I have this many 10 to the fourth and this many 10 to the fourth. So altogether, how many 10 to the fourth do I have? Oops, lost too much there, sorry. Well, I've got 1, 3, 3, and 2 times 10 to the fourth. And there is my answer. Pretty simple stuff. You just have to make sure those exponents match. In this green problem here, I didn't do the exponents. I didn't need to alter them. They already matched. I just added. In this problem 1, I went ahead and manipulated the one equation, the one number, so that the exponents matched. Subtraction is done very much the same way. Notice these exponents do not match. How can I turn this 6 into 8? Well, I'm going to need to multiply by 10 to the second power. But if I do that, then I have to divide here by 10 to the second power. So I'm going to get this 8 and 64/100ths number times 10 to the 8th. And I'm going to subtract. Now this is going to move 1, 2 places. Have a 0 placeholder. So I'll have 0.0321. Oops, I'm going to need to move this over. Times 10 to the 8th times 10 to the 8th. Now my bases and exponents are identical. I'm not sure what that was. Let me redraw that. And I'm going to need to subtract. Now, please, please, please tell me you know how to subtract. You can't just write down 1, right? You have to borrow. Oh my gosh, it'd be so scary if you didn't know how to do that. I'm going to borrow from this number here, turning it into 3. I want to turn that into a 10, but this guy needs something, so I'm going to borrow from him as well, turning him into a 9, and then him into a 10. Now I'll do 10 minus 1 is 9, 9 minus 2 is 7, 3 minus 3 is 0. Bring down the 6, bring down the 8, times 10 to the 8th. And there you go. Pretty easy. Now, one thing you have to watch out for, let's see what's going to happen on this one. I think it'll happen. If it doesn't, I'll draw attention to it. Okay, my exponents don't match on my bases. So I need to turn this -4 into a -3. This one's smaller than this one, right? You could do it the other way around. I just prefer to do it this way. So I'm going to multiply by 10 to the first, which means I'll have to divide by 10 to the first on this part of the number, moving my decimal point. So I will have this problem, 3 45 times 10 to the -3rd, and then I'll have 0.9, 8, and a 7. I'll put that 0 placeholder in, times 10 to the -3rd. I'm going to get 10 to the -3rd. I'm going to get 7. 3, carry the 1. I'm going to get a 4, carry the 1. 4. There we go. Now the situation I was talking about didn't happen. Let me make up one more sample problem and then we'll end this video, because I want to make sure I draw attention to how to handle a special situation. You should already know, but let's say I have 8, 9, 5 times, oh, let me change that to a 9. There we go. Times 10 to the 2nd. And I want to add that to, let's say, 22 and a half times 10 to the 1st. Okay, my exponents don't match. I'm going to multiply by 10 to the 1st, right? Divide by 10 to the 1st. And so my new problem is this. Just spacing it out a little bit. Okay. Believe that's right. Do I have a mistake there? No, I think I'm doing this okay. All right, I'm adding together. Now, when I add 0, I'm going to carry the 1. I got 11, it'll be 12. I'm going to carry the 1, 11, I'm going to get 12. I've made no mistake, but this answer is not correct. Why is it not correct? Because remember, for scientific notation, my decimal must be greater than or equal to 1 and less than 10 at the same time. So this is no good. Now we've made no mistake. I need to get this decimal point to move here. Well, that would cause me to divide by 10, wouldn't it? I'll do that, but then I'll multiply by 10 over here. And if you want to put the exponents in, that's fine. Causing my new number, and really, it's not a new number, it's the same number, but it looks different, to be 1 and 2200 times 10 to the 3rd. So just be careful that when you add or subtract that your answer ends up in scientific notation, just like when you were multiplying. All right, I think that's it for adding and subtracting scientific notation. Mr. Lawrence signing off. Good night, everybody.